A few months ago, I showed a remarkably simple experiment that appeared to reveal a longitudinal electromagnetic force in a current-carrying wire. That result has now changed. The experiment used a tungsten wire held under tension, and when current flowed through it, the tension fell more than the measured temperature rise appeared to explain. Heating the wire externally produced a smaller change, leaving an apparent residual force. But the whole conclusion depended on knowing the wire's true temperature. After the original video, a specific concern was raised about the temperature measurement. The thermocouple attached to the wire had its own thermal mass and could potentially cool the point it was measuring while also responding more slowly than the wire itself. Neal took those criticisms seriously and repeated the experiment using much thinner thermocouple, thicker test wires, and an improved thermal enclosure. He also checked the results independently by using the wire's electrical resistance to infer its temperature. The new measurements agreed. With the improved temperature measurement, the change in tension followed the change in temperature almost identically, whether the wire was heated by current or by an external heat source. For the thicker wires, the previous offset disappeared completely. For the thinner wires, only a very small offset remained, consistent with the thermocouple itself slightly disturbing the temperature at the point of contact. The conclusion is therefore clear. The original temperature measurements were wrong, and the experiment no longer provides evidence for a force beyond ordinary thermal expansion. Neal is now seeking to attach a retraction notice to the original preprint, and he deserves considerable credit for repeating the experiment, checking the results independently, and correcting the claim publicly. So, where does that leave Ampère's longitudinal force? The result removes one piece of the claimed evidence. It doesn't by itself refute Ampère's force law. To do that, we would need a clear quantitative prediction for this exact geometry, and an experiment sensitive enough to detect the predicted force and a reliable null result after all conventional effects have been accounted for. That's not what this experiment was designed to establish. The honest conclusion is narrower. With the improved temperature measurement, this experiment now shows no detectable force beyond ordinary thermal expansion. If a longitudinal electromagnetic force is present in this particular setup, it must be smaller than the current apparatus can resolve. That pushes the possible effect into a much smaller regime than the original experiment appeared to show. And this isn't bad news for science. A result was challenged, the experiment was repeated, the measurement was improved, the conclusion changed. That is the process working exactly as it should.